Hey everybody! The purpose of this video is to give you some solutions to the Pascal's triangle slash combination slash super counting slash mathematically fun quiz from this week. So the idea is you've got this cool grid in a triangle of numbers called Pascal's triangle, interestingly named even though it was independently discovered I think many years before Pascal by the Chinese, and I think it was discovered by even more people than just Pascal and the Chinese, as is often the case. Anyway, you can read the quiz proper if you want to see the relationship between the numbers as they go from row 0, which is just this one, and row 1, which are these two ones, all the way down to row 10, which is this guy. The first question is, what is row 11? So using that same relationship, row 11 is going to start with a 1, and then diagonally adding and going down, you're going to get the next few numbers that you need. 330, 462, 462, 330, 165, 55, 11, and 1. So there's your relationship there. What's cool about that is you pick up one additional term each time. So the row 0 has 1, row 1 has 2, row 2 has 3, and all the way down, which is actually kind of slick. There are all kinds of connections to this, to mathematics, some of which you already know, some of which you haven't learned yet. If you're interested in seeing some more than what's just in the quiz, by all means come see me. I'd love to sit down and chit-chat with you about it. Let's see, the next bit is about the sums of the rows. I had to really cherry pick about what to talk about Pascal's. There's so much cool stuff, from fractals to number patterns to types of numbers. You've got successive natural numbers here, you've got triangular numbers here, I mean all kinds. I think these are the pentagonal numbers right here, all kinds of neat stuff. Regardless, so sums. So this sum right here, let's see, we'll do a sums column over here. So we'll go all the way over. That sum is just 1, this sum is just 2, this sum is 4. I think I asked you to go to row 6, but I only showed you up to that 8. Well, let's keep going. This sum is, let's see, 5 and 5 is 10, 16. And now we're down to row 4. Row 5 is going to be 10, 20, 32. Now we're up to row 6. Now check out the pattern. 1, 2, 4, 8, 16, 32. What's happening each time? Each time you're getting twice as big as before. Think about why that makes sense. Think about why that makes sense. Each successive row starts with the same two ones the row above does. But each number down here is found by adding the previous numbers up diagonally down. So imagine this. Imagine this. Imagine that there was a 0 to this side of this one, and there was a 0 to this side of this one. Adding 0 is like adding nothing at all, literally. To get this number, you add 0 plus that 1. To get this number, you add 1 plus that number. This number, this one plus this one. You see how many times for each number I'm pointing to here, how many times I touch the numbers up here? This number 6 is included in both this one's sum and this one's sum. This 1 is included in both this one and this one. This 15 in this one and this one. This 20 in this one and this one. In other words, every number in the row above is used twice in a sum below, which means this row down here has every number in this row once and then every number in that row a second time. So it only makes sense that this should be 64, because I used all of those numbers 32 once and then I added them again. It doesn't matter what order you add them in as long as you add them again. So they added down here twice. And every successive row is going to end up being twice as big as the row in front of it. Does that make sense? Hopefully. List row 11's sum. So row 11 was this guy way down here. We just continue the pattern. 256, 512. This is a pretty important one in computer science. 1024. Pretty fun little number in computer science. And finally, 2048. 2048 is going to be row 11's sum. Row 11 is what we got done right there. The last question is, what is the sum of the values in row n? So row n is going to be the nth row, which is essentially asking, if we go down forever to the bottom, quote-unquote bottom, if the row was n, could we figure out what the sum was? Not what the row itself is, although you could very easily figure out what the row itself is. It's going to be n choose 0, n choose 1, N, choose 2, all the way up to N, choose N. And that's using that combination symbolism that we looked at in the quiz. What I'm asking is, what's the sum of that row? Now here's where you have to look at the sums you got here and their corresponding row numbers. Okay? We've already decided that these guys to these guys to these guys, each time you go up, you're multiplying by 2 to get to the next value. So all we've got to do is reverse engineer. This one is 2 more than this one. This one is 2 more than this one. This one is 2 more than this one. This one is 2 more than this one, and this one is 2 more than this one. That's 2 more than that one. So that's 1. Can we write 1 as 2 to the somethingth? Because if we could, then we've got a function for the base. This is actually called induction in number theory. You get a base case, and then you increasing by integers as you go down, you end up with a formula for the remainders. So this, yeah, can be written as a power of 2. It's 2 to the 0th power, which is the same 0 as the row number that's over here. Pretty slick, huh? So you got 2 to the 0th here, and you end up with row 0 over there. Well, that's pretty rad. This is therefore twice as big as this. So it's 2 to the 0 times 2, which is 2 to the 1st. This is 2 to the 0, excuse me, this is 2 to the 1st times 2, which is 2 squared. 2 cubed. 2 to the 4th. 2 to the 5th. And now hopefully you see the pattern. In the nth row, the sum is going to be 2 to the nth power. And the reason I love this, I can't give you one reason actually. There's so much cool stuff. One of the things I have you guys look at is the hockey stick pattern, which if you start with any one and go down diagonally and then take a hard right, the sum of the handle has to equal the blade. I mean, that's one of the things in the quiz you can look at if you're interested in. What I love about this so much is its prevalence in so many areas, of everything from number theory to probability to counting to calculus. It shows up in calculus for that matter. So it's a really, really neat result, especially when you can see the patterns between the exponents in that sum and the row numbers over here. Just so much cool stuff. So anyway, that's a closer look at those coefficients that we looked at when we were doing the chickens in class. So the 4, the 6. Here was my chicken flock right here. So when you have this cool little relationship, there's 6 ways to get 2 boys and 2 girls. There's 4 ways to get 3 girls and 1 boy. It's neat to be able to see that relationship kind of come to life in this way. So hopefully that helped, and we'll catch you in class.